It's section 1.7 homework help. I'll do two problems for you today. You had one problem in your homework where they gave you a function, they just called it y equals f of x, some random function, and they labeled some points. And then according to the rules that we learned in class, they wanted you to figure out what f of 2x negative 3 f of x plus 1 or 2 f of x minus 1 plus 1 would equal. And in the homework they're going to ask you to sketch it. I'm not going to go through and sketch it for you. I'm just going to find all the points or transfer the points using the rules that we learned. And then you can draw a sketch, and I'll talk about what's going to happen, but so you can draw the sketch and you'll see. So I'm going to take all four of these points, and I just went from left to right. It doesn't really matter the order that you do this in, and this is something I would like you to do in the homework as well, is transfer all the points. But for letter A, it wants us to find f of 2x. And so if we remember in class, we said, okay, if it's in parentheses, remember that that means it's affecting x. And then when it's in parentheses, it's always the opposite of what it would look like. So I can see that it's multiplying x by 2, at least it looks like that in the function. But I know that realistically that means it's dividing all the x values by 2. There's nothing outside the parentheses, not in front or behind, so I know that y is not actually changing. So when I look at this first point, negative 4, 2, that y value won't change for any of these points. The only thing that changes is that the x value is going to become half as large. So divide that by 2, that is going to give me negative 2, y value stays the same, so it's 2. Again, divide this by 2, that is going to give me negative 1/2, y value stays the same. Divide 0 by anything, it's going to still be 0, so divided by 2, still 0, y value stays the same. And divide the x value by 2, y value stays the same. And so you end up with these points. Whoops, this is supposed to be negative 2, sorry about that. So I guess that would be negative 2. But you end up with a bunch of x values that get divided in half and the y values that stay the same. And we know by rule what that's going to do is it's going to take this function and it's going to squeeze it together. And if you actually graph it, you'll see that that function will look kind of the same in terms of the height, but it's going to get squeezed together. Or we would say it's shrunk horizontally. Alright, so for letter B, again, I want to take a look at this and say, okay, I notice that there's a number outside the parentheses and it's being multiplied, and there's a number inside the parentheses and it's being added. And you might remember when we were talking about the order of when to do this, if x and y are completely separate like it is here, really doesn't matter which one you do first, but typically you want to take care of any multiplication, kind of like your order of operations. So I'm going to start by noticing that this number is outside the parentheses and it's multiplied by this function. So when it's outside the parentheses, it's changing y, and it's exactly what it looks like. It means it's going to multiply all of these y values by negative 3. So if you wanted to start writing the points, you could ignore the x value for right now. Multiply negative 2 by negative 3, and that's going to give me 6. Multiply by negative 3, and that's going to end up giving me negative 3. Multiply negative 1 by negative 3, and that'll give me a positive 3. Multiply 2 by negative 3, and that ends up giving me negative 6. So that takes care of this 3. And again, what that's doing is that's taking the function and that's stretching it vertically, and the negative also means it's going to reflect it over the x-axis. And again, you'll see that if you actually go through and graph it. It's nice to be able to recognize that by looking at it, and then of course, obviously, when you look at the graph, it's a little easier to see. Alright, the other rule that we saw here was we have an x plus 1 in the parentheses, and like we always said, if it's in parentheses, it's the opposite of what it looks like. It looks like you're adding 1, that means you're really subtracting 1 from all the x values. In other words, this function is going to move 1 to the left. So if I go to my x values and subtract 1, so negative 4 minus 1 gives me negative 5. Subtract 1 will give me negative 2. Subtract 1 from 0 will give me negative 1. And eventually gives me a 2. And now these 4 points are on the function b here, y is equal to negative 3 f of x plus 1. And again, just refreshing you with the rules, the negative 3 is going to stretch it vertically, and the fact that it's negative means it's going to reflect it over the x-axis, and the x plus 1 is going to move it to the left. Alright, so letter C here, the first two very straightforward, and for the most part they all are, but letter C is a little bit different because I have two things affecting y. I have a number outside the parentheses here, the 2 in front, and the plus 1 in back. And this is important because I have to do one of these things first. Do I multiply by 2 first, or do I add 1 first? If I do the wrong one, I'm going to end up with the wrong answer. And so think of your normal order of operations. You always want to do the stretching first, or you want to do the multiplication first. I needed to start by multiplying the y value by 2 and then adding 1. Yes, I'm going to add 1 to the x value. Again, opposite of what it looks like. And it doesn't matter the order that you do it. You just need to make sure that you take care of all the y's together and the x's together. So I'm going to go through and do all the x's together first. So if I look at my x value, again, opposite of what it looks like, it's actually going to the right one. If I add 1 to negative 4, it's going to give me negative 3. Add 1 to negative 1, it's going to give me 0. Add 1 to 0 and add 1 to 3. They're all my x values. And now again, just remind yourself, I need to multiply by 2 before I add 1. So multiply by 2 gives me negative 4. Add 1 gives me negative 3. Multiply by 2 would give me 2. Add 1 gives me 3. Multiply by 2 gives me negative 2. Add 1 should give me negative 1. And then multiply by 2 gives me 4. Add 1 will give me 5. And these 4 points will be on the transformation for that particular function, where the 2, because it's outside the parentheses and it's being multiplied, means it's going to stretch it vertically. The 1 is going to move the function up 1, and the minus 1 in the parentheses will move it to the right 1. Alright, so that's one example that you'll see in your homework. A second example that you'll see in your homework that this might be helpful for is they're going to ask you to write an equation for the following graph. You have a couple of them like this, and it comes down to just being able to identify what is the function. So for example, when you look at any sort of function, if you see a u shape, you should know that it has an x squared in it. That should be the highest exponent. If you see kind of that goofy little s shape, you should recognize, oh, that's a cubic function, so I have to have an x to the third. If I see the v shape, I know that's an absolute value, and so on. Being able to recognize that is very important. You should be able to do that. So when I look at this function, I can recognize, hopefully, that that's the square root function. So to kind of write the general equation, I know it's going to be y is equal to a times the square root of x minus h plus k. Again, if that was a v shape, I'd have the exact same thing, but I would have absolute values here. Or if this was a cubic function, I would have parentheses cubed here. Alright, and it's set up in the vertex form, and of course they gave us the vertex point right here. So I'm going to start by plugging 4 in for h and 1 in for k. So far my equation is y is equal to a times the square root of x minus 4 plus 1. Remember, opposite of what it looks like, if I set that equal to 0 and solve, I should be getting 4. So just want to double check that, and then this number should be exactly the same as that y value there. And of course the only thing I'm missing is letter a. And typically if they give you what looks like a random point on that graph, it's because they want you to plug it in for x and y and solve for a. So just make sure you get them in the right spot. I'm going to take 2, plug it in for y here, and that's going to give me a times the square root of 7 minus 4 plus 1. And now you just have to solve for a. Again, do your order of operations correctly. When you're solving, I want to subtract 1 to start with. So subtracting 1 will give me 1 times a times the square root of 3 multiplied, so you're going to divide both sides by the square root of 3, and you are going to end up with a is equal to 1 over the square root of 3. And like any time we're dealing with radicals, if you've got a radical in the denominator, you know that you are supposed to rationalize. So you are going to multiply both the numerator and denominator by square root of 3 over square root of 3, which we know we can do that because it's a fancy way of multiplying by 1. And that'll turn into the square root of 3 over 3. So not the nicest number in the world, but it shouldn't matter what kind of number we get, solving same steps. And then all you're going to do, that's not your final answer, you are just going to take that and plug it in for a. So your final answer should be y is equal to a, which we said was the square root of 3 over 3, times the square root of x minus 4 plus 1. And there's the answer that you'd be looking for. That equation would be the equation of that particular graph. Alright, that is homework help for 1.7. If you have any other questions or problems that you weren't sure of how to do, feel free to stop in and ask for help.